Okay, let's get into this. We have, for now, been using just registered metrics as our inputs to our neural networks, right? So if you're playing a Pong game, you're providing the position of the paddles and the ball to your neural network, and it is using those as inputs to figure out what to do. And in many ways, that's great because you've really boiled down the problem for your neural network. It makes it way easier for them to be able to solve these problems. Now I just want to start getting into a little bit of a harder problem where we're using a visual observation, and that visual observation is the only input the neural network has, and it's got to be able to figure out what action to take. Now, as usual, I start with what I consider a minimum viable product. What is the simplest thing that I can do to get me on this path? And again, that's good because it provides a good starting point. It helps you build an intuition about what's going on, and it also means that you know that the entire process works, right? You're not just building a huge thing and then finding out that none of your pipes work. So before I get into it proper, I do want to say, up until now, I've had a folder of batch files that I've used to help simplify and automate things. I've gotten rid of those, actually. I've created this automation folder where I have a couple of editor scripts. These allow me to kind of organize things and have them ready to go. So you'll see here under ML Agents, Start Training, Start TensorBoard, Open TensorBoard Browser, and Open Models folder. These are all things that I commonly do, and so I just want to have shortcuts here, and so now I'm not messing around with batch files and whatnot. So if you get the latest version off of my GitHub, that will have this script and these menu items. You will need to go in to edit preferences, and that will have down here this ML Agents. That's me. You need to put in your root folder, right, where you downloaded your ML Agents to, and then what config file do you want to use for the run, and then optionally a run ID. I leave it blank because now I'm using the scene name, and so I don't have to go around for each one and rename it. I'll just use whatever the scene name is. So let's see here. Well, let's get into this, and then when I use those menu items, you'll see how I use them, and I just wanted to call those out first because I didn't want people to be like, hey, I don't have those menu items. It's in my project. It's in my GitHub project. You can just download it, and then you too will have those menu items. So let's see here. We have our observation scene. We have our main camera, all right? And we have a directional light, standard issue, our academy, and in this case there's nothing super crazy going on here. This is pretty much a default academy with an observation brain and a trading configuration of a width and height of 80, quality level 1, time scale 100. So this is all, should be all of the default values for an academy. And then we have our game environment. So what is the game? The game is, very simply, there's a box. Sometimes the box is visible, and sometimes it's not. And so when the box is visible, you say, yes, the box is visible. And when the box is not visible, you say, no, the box isn't visible. That's the entire game, right? Minimum viable product. This is just showing that it does make observations and takes an action based on those observations. All right. So in this case, we have a cube, and the cube is what comes and goes. And then we have a game camera. So because we're using a visual observation, this game camera is looking right at the cube, and so the neural network will always receive an observation of whatever that game camera sees. So that's going to be showing either complete white if the box is there, or in this case, it's not actually going to be, oh no, it is, it's the skybox. I probably should have set that to background instead of skybox, but whatever. It's not obviously super white, so it'll either show that or that. That's the entire game. So the game camera, pretty standard issue camera. Cube, standard issue cube. So our game environment, you'll see here, it has an observation brain, right? That's our learning brain. And then for camera 1, that's our game camera. So that's this guy down here, not our main camera. So you basically hit add camera, drag and drop that in on the spot. You could use a render texture instead. In this case, the game camera is fine. I really like the fact that you can use a render texture instead, because I think that will provide a lot of capability for flexibility. I would love to see about maybe seeing if I could tie in my webcam to my render texture and using that as an input. So now we're taking input from the real world, which I think the performance will be terrible, but it'll at least be fun. Max steps, so we're going to do 10 trials, right? Either the box is there or it's not, 10 times. And then we reset on done, and our decision interval is every single frame. And then down here, if we're right, the reward is 1. If we're wrong, the reward is -1, and the subject is the cube. So let's go ahead and train this puppy up after. I'll just hop into the code here. The code is going to be pretty simple. This is not a crazy, complicated thing. When we're bringing in an observation, right, we're getting, we've already set it up here, so we don't need to pass it in on the code side, right? So in start, we reset on agent action. We figure out, we take the game's action, and we say, the agent's action, did you think it was there or not? And if it's a 1, then it says, yep, it's active. If it's a 0, it says, no, it's not active. I just have the correct and incorrect here as placeholders. I'm actually going to comment out the debug logging. We don't want to do that while we train. And then the agent reset. So that's every game or so, right? You'll say, is shown, and then, it sets the subject, the cube, to active or not. That's it. That's all there is to that guy. Now, when you are setting up the observations in the brain, we'll go into the brain a little bit, it'll ask for, vector observations. How many vectors are we passing? And we're doing nothing. We're doing this all visually. The visual observations, when you hit add new, right, it'll give you the option for the width, the height, and whether or not you want it grayscale. It starts at 84 by 84. Now, I thought that by making those values smaller, it would make everything faster because I'm passing less data around, and also get it to train faster. For some reason, though, you start getting smaller than 84 by 84, and I haven't found where the barrier is, but it'll stop working. It'll just throw an exception, and the training won't work. So for now, we're just proving out that the plumbing goes, so we're going to use 84 by 84 as the defaults because I know they work. The space type is discrete, right? And then the branch size is 1, where you basically say, is it there or is it not? And that is all there is to the brain. So that is everything. So I'm going to get this thing fired up. So I don't have TensorBoard running right now, so I'm just going to click Start TensorBoard. And you'll see that opens up console and starts up TensorBoard, and then open TensorBoard browser. Actually, I'm going to close those down real quick because I did not clear out my training stats, and that is actually kind of important in this particular case. All right, so we'll do ML agents, and we'll go to summaries. Let's just clear that out. And we'll go to models, and we'll clear that out too. I've been busy. Okay. All right, so now we'll restart TensorBoard. All right, see, that's up and running. Great. We'll open up TensorBoard in the browser, and there's no data in there now. And we can just click Start Training. Oh, hold on. Let's check Academy. Oh, my brain is not in control. Let me put the brain in control of the training. Okay, Start Training. Open a browser or a console window. It says Start Training by play in the browser. Now, of course, all of these scripts, the things that you just saw me do real quick, makes it really, really simple and easy to do. It, however, is only written for PC, and is my first cut at those, so there might be some computer-dependent settings in there, so if you have any issues with them, just pop a comment in below and I'll help you troubleshoot. Only for PC. If you're on Mac or Linux, you might kind of be on your own. Sorry. I don't have a Mac. And so I'm not sure what additional settings that you might need in the console, or if it would even work at all. All right. Let's see here. So that is going to go through and do its training. So it's already 7,000 steps in. The other thing I wanted to talk about is the input parameter space, right? When we were doing vectors before, it felt like, when we were getting more and more complex, that we were providing the system with a lot of data, right? When we were doing Pong, it was the position of the paddle. I think we may have even gotten the speed of the paddle, the position, X, Y, Z of the ball. Well, probably not depth because it was stuck on a plane, but position of the ball, velocity of the ball, all of these things, and we just handed it over. So we had like 12 or 15 observations that we were handing along, and that's a fair amount, but it was also able to reason over those and train over them. Got to remember, when we're doing this, we're sending it a picture, which is, either all white or not, but it's, 84 by 84, and so, that's a really huge number of parameters. It's 84 by 84 by 3, right? Because it's, 0 to 255, I'm guessing, or 0 to 1, depending on how they're sending the data over. So it's either a byte or a float, and then there's a whole bunch of them. So your algorithm in this case has a much bigger landscape that it needs to explore and understand in order to solve a problem. Now, even in a simple problem like this, any pixel of the landscape should be able to tell it how to solve the problem. It's a very simple problem, but the system doesn't know that. So it still has to explore this very large landscape and try a whole bunch of stuff because, for all it knows, byte 700 might have some special meaning, and it's looking to see if it can get some special meaning. And so it's going to be trying a whole bunch of stuff as it explores this landscape. So, with the parameter space being orders of magnitude larger, expect your training times to go way, way, way up. And that's even just for, individual parameters and stuff. If there's some things that you're, hoping that it will recognize and move around, which that is where I'd like to go, I'm going to say expect some pretty long training times because it's going to take a lot for the system to be able to see a scene, recognize something visually, and then take action on it. These are very non-trivial tasks, and we're going from kind of toy game examples and then pushing into more and more researchy type things. Like when I'm talking with researchers, this is the level that they're at, where they're taking the output of a video game, basically screenshots of a video game, and teaching systems how to play the game with nothing but those screenshots. So it is plausible, and it is something that small teams can do, but it is very challenging. And then you start looking at Obstacle Tower and some of the other stuff where you're trying to do some of these tasks purely visually, and you have large research organizations with teams of people who've been doing this for a very long time, who are specialists and experts in the field doing it, and even they have trouble sometimes. So if you struggle with this, I have to urge you to not beat yourself up too much. Understand that these problems are hard. The science is still not super well known. It's still growing. And that, yes, a problem like this we should be able to solve and then you can build on it and grow on it and do better and better from there. But straight out of the gate tackling a big problem, like there's researchers that are playing Dota, right, Defense of the Agents 2, and they've trained some AI to work in some scenarios with certain characters under very strong constraints, and this is absolute bleeding edge research, and they're doing a phenomenal job with it. But if you're just like, oh, I want this to be able to quote unquote play Minecraft and do all of Minecraft, that's going to be way down the road, and the science has to mature and the technology has to mature. But there are interesting things that we can do purely visually, and so that's why we should be going down this path. But for an intro series, I also wanted to make sure that we were a little careful that we didn't start there, because it is more challenging. All right, let's see how we're doing. We are just a couple thousand iterations away from being complete. And I will pull up TensorBoard now. All right, and here is our graph as our algorithm has learned thus far. Now remember, we're getting +1 when we get it right and -1 when we fail. So when we start off, there's a little bit of a roll of the dice on whether it ended up above or ended up below. And we have 50,000 iterations or so. I don't know if we're not quite there yet. And we've noticed that our average score right now is a whopping 2.5, right? So it is getting it right more than it is getting it wrong. However, over the course of 50,000 iterations, which was plenty for some of the simple problems that we were dealing with picking a number or some of the Lunar Lander like early test stuff, right? 50,000 for those highly, highly simplified problems was plenty, right? And in this case, this is the most simple example of an observation game that I could think of, right? Are all the pixels white or not? It was as simple as I could come up with, and 50,000, we're playing slightly better than random, right? So these are way harder than some of the other things that we've tackled. All right, so we're going to see how this plays. I ran it recently, and so that was my old neural network file. I'm going to go up to ML Agents. I'm going to open up my models folder. This pops open this, and I'll bring over my observation.neuralnet. Close that bad boy up, and we'll go over to this brain, bring in this observation neural net. I'm going to go back to my code and uncomment these, because what I found interesting was how it got things right and how it got things wrong. All right, we'll go back to the Academy, turn off control. So we're saying we are now in inference mode, so we're going to have it play the game. And really the output that's most interesting is going to be in the console. And so how does it behave and what is it doing? Well, I have this on collapse so that we can easily add up the numbers. You can see that more often it is correct when it is true, right? So in this case, true meaning that the white square is being shown. So when the white square is being shown, it says that the white square is being shown, right? And it's doing that. That is how it is usually correct, and then is often correct when it's false, and it says it's false when the object is actually not there. Here's another one where it says true when false. So this is when it's wrong. It is more often because there's nothing there and it says there is something there, which means to me, that says to me, this system has a tendency at this level, at the 50,000 training mark, to tend toward saying things are true, whether or not they are true or not. And then incorrect, false when true, is the least common item, and so it doesn't tend to say things are false. So it generally tends towards saying things are true, and therefore it is more often correct when things are true, but it's also more often wrong by saying things are true when they're actually false. But as you can see, when you add these up, we are in fact better than chance, right? These two are kind of neck and neck. Here, I'm just going to pause it. Right, so we have about 2,500 correct, and then let's call it 1,500. So 2,500 correct and 1,500 incorrect. And that's how far that we've gotten with this amount of training, and that's what our score of 2, yeah, we ended up at about 2, has given us. So I'm going to go ahead and give it a longer training run. I'm going to let this puppy probably run overnight, and hopefully I will get a perfect player on this ultra simple game. And again, I think part of it is it's still exploring the landscape a little bit and hasn't figured out that, you know, all of the input at this point is of pretty much equal weight. And, you know, that's, something that it should learn given enough time. So that's where I'm going to go. Questions, comments, thoughts, as always, leave them in the comments below. Or if you're a patron, please drop them off over at patreon.com. And I'm happy to hold discussions. We recently had a poll talking about what content we wanted and what direction we want to be going with the series. The votes were heavily on the stick with machine learning as opposed to get into entity component system or other things. So I think for now that will be our continued direction, is to still explore more topics in machine learning and build more examples of things, and hopefully get some of these examples so that they're a little more full-featured and game-ready, would be where I would choose to go with that. Anyway, thank you all very much. If you'd like to support this show, if you found some of this content useful, then please drop us a like, follow, share. All of that is really grateful. And then if you found that consistently over time you've gotten value out of a couple of these videos, please consider hopping over to Patreon and becoming one of my patrons. Until then, good luck and happy learning.